Okay, so for this lesson, I'm covering word problems because word problems are usually very difficult for people. So, definitely want to cover those. And I'm specifically doing word problems involving absolute value equations and inequalities. Now, most word problems that you're going to encounter with absolute values are actually inequality types. Very rarely do you determine or do you find word problems that are actually equations? The ones that are equations are basically inequalities, except that they're specifically asking for maximum and minimum values. So you don't need the range in between the values. You're only looking for the endpoints. So if it's looking for max or min, it's going to be like an absolute value equation. Otherwise, it's going to be an inequality, though you could solve it as an inequality and still get the answer. So I've just got 4 examples here, and we're just going to go through the examples because that's the best way to really practice these kind of word problems and to see how they're set up, is just to do examples. There's not really any guidance in like how these usually look. So the first one here, Leona was in a golf tournament last week. All her 4 rounds of, that's supposed to say golf. The funny thing is I copy and pasted this from the textbook, which means that the textbook has this has this error because I literally copy and pasted from the textbook. Okay, so all of her 4 rounds of golf were within 2 strokes of par. If par was 72, what are the maximum and minimum scores that Leona could have made in the golf tournament? So it's asking for maximum and minimum scores. So this is going to be an equation, an absolute value equation. And the way to think about this is that we've got par, and we're within 2 strokes of par. So we could be up here, a distance of 2, and we could be down here, a distance of 2. Now this one is easy enough to solve mentally, because it's just basically, you're like, okay, 70 and 74. But I just wanted to kind of, show it when you're looking at a picture here. And we do need to have to kind of think about, well, there's 4 rounds of golf, we've got to think about that as well. But all of her 4 rounds were within 2 strokes of par. So there's going to be 2 on either side. So an absolute value equations and inequalities are all about measuring the distance between 2 things. So when we usually write this as an equation, we're looking for her actual score and then subtracting basically the middle point, which would be par, which is 72. And that is giving us the distance. So if her score was 74, 74 minus 2 is 2, so it's 2 away. If her score was 70, 70 minus 72 is -2, it's still 2 away. And because we're looking for the distance, we take the absolute value. So we want that distance between those to be equal to 2. So every round was within 2 strokes of par. So this is indicating basically for a single round. Let me actually literally write it that way. So we're going to solve this inequality using algebra, although you can just visually see what the numbers, the answers are going to be. But we're going to solve it using algebra to practice that. And then we're going to answer the question, maximum and minimum scores that she could have made in the tournament. And that question is, are they asking for scores per round, or are they asking for like the total kind of scores? And since it's not clear, we'll assume that it's scores per round here. So when you have an absolute value equation, you first have to get the absolute value part by itself, which we've got. And then you're splitting it up into 2 equations. One with the positive version. Let me rewrite that too. With what's on the right, and then one with the negative version, which is literally what I said out loud. You know, our choices are 74 and 70 just because we can solve this mentally. And the distance between those is either 2 or -2, depending on, you know, the order that you're subtracting. So we add 72 to both sides here to solve for x. We've basically created two linear equations. And when I work absolute value equations, I do both sides at the same time, and I do both equations at the same time because I'm just adding the same things. And so we get 74 and we get 70, which you can see visually with the picture, and you know, you can think of that mentally. If all of her rounds were within 2 strokes of par and par 72, then she you know, made between a 70 and 74, and we're looking for the maximum and minimum scores, which would be 70, 74. So this is something that's kind of trivial. You wouldn't necessarily solve it using algebra like this, but it's a good demonstration of what you're doing in your head is actually solving an absolute value equation. Now, for word problems, we generally always write our answers in sentences to make sure that we're answering the question. So the question doesn't specify total scores, and you know, we can kind of do it both ways. It doesn't say whether it's round or total scores. If we're looking at maximum and minimum scores that she could have made in the golf tournament, and we're looking for the total, you just take each of these and multiply by 4 because there's 4 rounds. So the minimum score, if she made the minimum every time, which was 70, you multiply that by 4, that's going to be 280. Maximum score, if she got 74 every time, then you multiply it by 4, that would be her maximum score. And that one I can't do in my head, so I don't know what 74 times 4 is. 380 maybe. Don't trust me on that. No, the 360. So we'll do it both ways. We'll answer both because it doesn't specify. So in one round, she could have made a minimum of 70 or a maximum of 74. After 4 rounds, she could have a minimum of, and then 70 times 4, which is 280, or maximum of, and then I'm going to use my calculator to do 74 times 4, since there's 4 rounds, 296. Yeah, I definitely did that wrong in my head. Mental math is not always. Sometimes it's better to have a calculator, because trying to do some multiplications mentally in my head, I'm not very good at it. So that's how we would write our answer here. And again, the question is kind of ambiguous on whether it's asking specifically for 1 round or 4 rounds. So that's why I answered both, just to be on the safe side, because it's not entirely clear when it says scores, you know, what they're looking at here. So are there any questions? Okay, well, let's move on to my second example here. And this one, we don't have to write the equation, we're actually given the equation here. So Amtrak's annual passenger revenue for the years 1980 to 2000 is modeled approximately by the formula R, we're using R to stand for revenue, equals -40, and then absolute values x minus 11 plus 990, where R is the annual revenue in millions of dollars. So when they give us a unit like that, they're just saying whatever our answer is in units or millions of dollars. You do not want to convert your answer into millions by actually like adding all the zeros. It's going to be, we don't want to do that. We're going to use the units millions so we don't have to write out the zeros. And then X is the number of years since January 1st, 1980. In what years was the passenger revenue 790 million? So this is asking, so X is our years, so we're going to be looking for X, and we want to know where is revenue equal to 790. So you're taking your equation and you're setting it equal to 790. So R is going to be 790. And again, we're not going to convert it to the full number with all the zeros for millions. It's just, you know, it's a lot harder to work with that way. Then we have negative 40, absolute value X minus 11, and the absolute value then plus 990. So unlike the previous example, which we could essentially do in our head, this one you're not doing in your head. You need to actually solve and go through all of the steps. So we need to get the absolute value part by itself. So the first thing we do is add or subtract from both sides when we're solving. So I'm going to have to move the 990 away from the right to the left. So we'll do that by subtracting. So I'm just going to use my calculator just so I don't mess up my mental math. And that gives us negative 200 equals negative 40, absolute value X minus 11. So when you're taking notes here, especially, you know, I'm explaining a lot of stuff in words. When you're taking notes, some of the stuff you may want to write down. So you may want to, you know, write down like step 1 is to isolate the absolute value. And that's what we're working towards right here, is trying to get that absolute value part by itself. You know, so you might want to kind of write down the steps so that you have that and you can see what goal you're working towards and what you're doing. So we're still working towards getting the absolute value by itself. And right now we have a negative 40 in front of it, and we need to get rid of the negative 40. Now, absolute values don't distribute. So negative 40 cannot be multiplied through the absolute value. The absolute values do not distribute. So you can't put that through. We have to divide both sides by the negative 40 to get rid of it, because it's negative 40 times the absolute value. So we're going to divide it. So I'm just doing this in a different color just to kind of offset it. And so now, just to be safe that I don't mess up my math, negative 200 divided by negative 40 gives us 5. So we have 5 equals, and then the absolute value of X minus 11. So now we've isolated the absolute value, and now we need to create our 2 equations to solve. So this would be like your step 2 of the procedure, and there may be steps in between these, but these are the big ideas that you're doing, is to create 2 equations. So I've got one equation where I'm going to set up with a positive 5. 5 equals X minus 11. And then the other one with negative 5. So we have negative 5 equals X minus 11. And then we solve. So that would be basically your step 3 is you've now got linear equations that you're going to solve for X. And for both of these equations, I have to add 11 to both sides. So I just work these at the same time. And with 5 plus 11 is 16. And then negative 5 plus 11 is the same as 11 minus 5. So that gives us 6. So we have 2 years. And the X, it says, is the number of years since January 1st, 1980. So this is not like year 16 and year 6. These are how many years since 1980. So I would have to add like 16 to 1980 and then add 6 to 1980 to get the 2 actual years, because that's what the question is asking for. So 1980 plus 16 is going to be 1996. And then 1980 plus 6 gives us 1986. So the question says, in what years was passenger revenue 790 million? And that would be in years 1986 and 1996. So when I write my answer here, it's going to be passenger revenue. Oh, wow, you can tell it's a Saturday. I can't, I'm doing my multiplication wrong. I'm not spelling things. Passenger revenue was 790 million in 1986 and 1996. So when you write your answer to a word problem like this, you're basically taking the question and kind of restating it as a sentence. You're almost taking almost the exact same thing and just kind of rearranging the words with your answer in there. So are there any questions on this example? Okay, so then I'll move on to my next one. And this is where we're going to start with the inequalities. So we did 2 equation types. Now we're going to do 2 inequality types. So a box of cereal is labeled to contain 16.5 ounces. A consumer group takes a sample of 50 boxes and measures the contents of each box. The individual content of each box differs slightly from 16.5 ounces, but by no more than 1 ounce. So this is a 2-parter. If X represents the exact weight of the contents of a box of cereal, write an absolute value inequality that represents an interval in which to estimate X. So this is going to be written very similar to our first example, where if I kind of draw a number line here, we have our goal of 16.5, and then we're going to be no more than 1 away from that in either direction, because that's what they found. The individual content of each box was no more than 1 ounce difference. Now, it wasn't exactly 1 ounce difference. It was no more than, which is why we needed inequality here. So we set this up by finding the difference. So X is going to be the actual weight of a single box. And then we're going to find the difference between the box, what the box says it should be, which is 16.5. And we take the absolute value because it could be positive or negative based off of which side of 16.5 it's on. And then when we say no more than, that is going to be a less than or equal to. So it's going to be less than or equal to 1. It could be less than 1. It could be equal to 1, but it's not going to be more than 1. So we're going to write this as less than or equal to 1. So now we have an inequality here, which when we solve is going to give us an interval for which, we can estimate X. And you can, again, this is simple enough that you can look at the picture and you can say, okay, it's going to be between 15.5 and 17.5. That's just, you can do this in your head, but I want to show you the algebra that you're actually doing in your head without even realizing it, basically. So when we're solving absolute value inequalities, there are multiple ways to turn this in. Now we always have two pieces, just like with the equations. With the equations, you wrote it as two separate equations. They were separate. When it's an inequality, you either have two separate inequalities with an or you have a compound inequality where they're combined, which is considered an and. The less thans are always going to be compound inequalities. If it's a greater than, that's where you have them separate. So this, because it's a less than, is going to be a compound inequality. So when we create this, we take the inside of the absolute value, 16.5, and first it's going to be less than or equal to 1. But then to get to the other side, when you flip the sign, basically the inequality is roughly changing directions if you were kind of looking at it. And so the other side, we have a negative 1 less than x minus 16.5, but that's equivalent to x minus 16.5 is greater than or equal to negative 1. So essentially, when you get the negative answer, the inequality flips direction, because that's what happens when we solve inequalities. When you divide or multiply by negative, it changes direction. And the way that it changes for this kind of problem, we're allowed to combine them into a compound inequality. So you may want to write a note to yourself that a less than or equal to or less than, those get turned into compound inequalities. And then if it's a greater than or equal to, then it's an or situation. So I've got this compound inequality that I've created here, and to solve, you're working on the left, the right, and the middle. So we want to get x by itself. So we're adding 16.5, and we're doing it to the right and to the left, because we're basically doing these two inequalities at the same time. So that gives us the 15.5 that I had mentioned before, and then x, and then less than or equal to, and then the 17.5. You know, the two answers that you can see visually and that you can kind of get in your head. So that's solving the inequality. Generally, when we solve an inequality, we write it in interval notation. We don't leave it in this form. So interval notation, when you have a compound inequality, so our left endpoint is at 15.5, the right endpoint is at 17.5. And then less than or equal to are brackets, and they face basically towards the center. So that's how we would write this in interval notation. Now, part B says you're doing more than just solve. You're interpreting the answer. And when you're told to interpret an answer, that means you're writing what this means in words. That's what it means to interpret the answer, is to actually put it in context of the problem, which is good practice to do anyway for word problems. You don't just give the numbers, you want to say what this means. That's what it says for interpreting. So basically, what this has found, you know, we have just found the minimum and the maximum weight, and we don't know that every box is equal to these, but the exact weight of each box is between or equal to these. Yes, Stephen, you can ask your question.
So for that step, would it be easier when it says to interpret to write the step to basically just put into words?
Yes. Yes, that's exactly what we're doing here. So the way that I would write this would be to say the exact weight of each box is between or equal to, because it is a less than or equal to situation, and we need to include that it could be equal to 15.5 ounces and 17.5 ounces. That's what the interpretation means, is you're basically just putting in words what you just found, but you're adding the context. You know, we're taking it back to, we're including the units, and we're including, you know, the fact that we're measuring a box of cereal. You know, I could say each box of cereal. I could be very more specific there. If you want to get even more specific, you can say the exact, oh, I forgot a word here. I am just on a roll here. The exact weight. Let me try to squeeze that in. The exact weight of each box. But you can be more specific and say the exact weight of each box in the sample of 50 boxes, you know, have a very complicated sentence, but that would be the most specific answer to what this means. So, any questions? Okay. So, last one here, and this one is actually very similar to what you see in you know, real life. You actually deal with inequalities, absolute value inequalities in real life, and you have no idea. So the results of the political poll indicate that the leading candidate will receive 51% of the votes with a margin of error of no more than 3%. So this goes into statistics, and if you are, I think several degree plans have to take statistics. I think the computer science might have to take statistics. I know for sure business has to take a statistics course. And one of the things that you do with statistics is you poll a whole bunch of people, find the average, basically yes or no. So if, let's say they polled 100 people, then 51 of them said, you know, would vote for this guy. Margin of error is, it's calculated as something called standard deviation, but it's basically saying, well, we know that this is not, you know, it's not going to be exactly this much. There is a margin of error, but we've gone through all of the math and we've determined that you know, maybe it's not going to get exactly 51%, but it's going to be within this interval. We know that the actual number of people that will vote, or the actual percentage of people that vote for this, will be between this interval. It's just a way to kind of hedge your bets, because you may poll 100 people, but maybe you don't poll the right 100 people. You know, maybe your polling's wrong. So it's, you know, you poll enough people that statistically you have usually 95% confidence that it's between this interval. That's what we've got here. We don't know how many are actually going to vote, the actual percentage, so that's why it's X, but we think it's going to be around 51 plus or minus 3. So part A, write an absolute value inequality that represents an interval in which to estimate X. So this is going to be very similar to the other one here. So we're going to start with X, and then we subtract where we think the actual value is, which is 51. And then it says no more than 3%. Again, that's going to be less than or equal to, because it could be equal to 3% or less. And then this is less than or equal to 3. So in statistics, this is called a confidence interval. And when you take statistics, you are literally solving this absolute value equation. So this is one of the reasons that you learn this in algebra, is if you have to go on to a statistics class, you need to know how to solve these, because you will be solving them. So just like the previous problem, we're basically going to set up a compound inequality where one side is 3 and then the other side is -3. These are like the easiest kind to solve. And so we're solving for X, so we're going to add 51 to basically the 3 parts of our problem here. So 51 minus 3 is 48, which is less than or equal to X, which is less than or equal to 51 plus 3 is 54. So that's our inequality. If we were to put this in interval notation, it's 48 to 54 in interval notation. And so when we interpret the answer, basically the candidate could receive 48% to 54% of the vote. So I worded this slightly different, or very different than I worded the other one. But with percentages, that's usually how we work. Is, you know, you're between this. You can receive 48 to 54% of the vote. That's what this is saying. You could get 49. He's somewhere in that interval. Now, if you were to, you know, if you were in real life polling, this interval says that the candidate could win or could lose, because if he got 48% or 49% of the vote, he would lose. If he got higher than that, he could win. So we can't say, you know, you might say, oh, well, he got 51% of the votes, the candidate is going to win for sure. But due to the margin of error, it's possible that he doesn't. So when you're, you know, next election, when you're looking at the polling, they don't usually give you the margin of error up front. It's usually in small print, like at the bottom of the article or something like that. But pay attention to that, because usually they'll give the percentage and they're like, oh, there's a 55% chance that, you know, he's going to win and whatever. But then if you look at the margin of error, actually it's possible that they may lose. And so that's actually happened in several elections where we think one person's going to win, and then due to margin of error, it actually ends up being the other one wins. And it's not that our polling was wrong. It's just, if you actually look at the range, it was possible for that person to lose based off of the margin of error. So just a way to connect math here and what this math means to real life, you know, understanding what it means to have a margin of error, what it means for polling, all of that kind of thing. And then actually seeing that you're actually doing algebra here and you just don't know it. So are there any questions on this problem? Okay, so I had only these 4 situations to go through. They're, you know, pretty much the most common word problems that you would see, or situations. This one, the cereal box one, is similar to what you have on the homework. So just as an FYI, when you do the homework on these topics, you'll have one very similar to this. So now you kind of know what you need to do. If you want, so I'm going to just stop sharing right now. If you have questions on other things, I have time to answer those. Otherwise, if you feel you're good, you know, you're welcome to pop off. But I just want to give you the opportunity to ask other questions if you have them. So.